Good morning to all. So, we will continue brake design system aspect. So far we have discussed automobile brake system design. In that brake working fluid methods, brake types, brake torque requirement. Within that we have discussed about drum brake system, disc brake system. Okay. Now today we are going to discuss about dynamic analysis. So within the dynamic analysis, we will go for the mass transfer, how the weight is going to transfer. That aspect we are going to discuss, and also the brake distribution, particularly for braking optimum. Right, in that aspect also we are going to discuss. Two aspects we are going to discuss: mass transfer as well as the brake optimum. Okay, let's move on to the dynamic analysis. So, in the entire system what we are going to do, we are going to focus only two axle vehicles, right. So, we have a multiple axles also, right, but our focus to understand for automobile vehicle aspect. When you say automobile vehicle aspect, normally it is a two axle system. So, we will focus primarily for the two axle system. So, just this is only for the, we will do the static analysis, static condition. Okay. So, I introduce certain terms also. So, since we are talking about the two axle system, we have a wheel here, another wheel, right. Just schematic diagram. So, this is your two axle vehicle. It's a, probably you take it as a car, okay, and this is your the CG of the center of gravity of the car. Okay. Then from center of gravity, this is road level, the height is called h, this is h. Okay. Then the distance between two wheels is called wheelbase, normally called as a L. Okay. H is the height from the CG to the road level, and L is the wheelbase, and within that, so from center of the front axle, this is the front A, okay, and we take it as a B, right. So, from here to here the distance is L1, right, from the front center of the front axle to the before the center of gravity is L1, after the center of gravity to the rear axle's wheel center is L2, L1, L2. So, the L again it says summation of L1 plus L2, right. So, from the center of gravity the entire load of the vehicle is acting at the down. W is the vehicle weight, yeah, that is clearly given. Any other information? Nothing, right. So, at the moment this is in the static condition. Okay, this is the static condition. So, what do you expect the reaction forces to the front axle and the rear axle? What do you understand? Normally I will take it as a front. When I say front, okay, maybe I will write here front axle, I will refer as a FA, okay. Then rear axle I refer as a RA. So, these are the terms we are going to use in this entire dynamic analysis. Yeah. So, now the reaction force, we would like to see what is the reaction force when the vehicle is at the static condition. Okay. So, take the moment with respect to B, right. When you do that, of reaction force of WFA is a front axle into L. What do you expect? WL2, right? right? W into L2, that is what you expect. So, WFA is nothing but is a simple supported beam, kind of simple supported beam. So, W L2 by L, this is what you are expecting, yeah. So, this is the reaction force at the front axle. Similarly, for rear axle WRA, what do you expect? W into L1 by L, yeah, W L1 by L. So, this is you are expecting. So, maybe you can take it as equation 1 and this is equation so A and B, not 1 and 2. So, this is static condition. Now, assuming the vehicle is moving in the forward direction. So, when you are moving forward direction, what happened to the inertia of the vehicle? Right, inertia of the vehicle. So, W G by A. So, that is what we will take as the inertia, right. So, when the brake is applied, the vehicle, the deceleration will move in this direction. So, that is you take it as a deceleration A. Okay. So, now I have done the static condition, now we will move for the dynamic condition. Okay. Dynamic condition. Same way what we did, same thing we will do, yeah. So, when you do that, when it here instead of WRA, I will put as a reaction force N, I will use N, okay. This is front axle with respect to rear axle, NFA L equal to, what do you expect? You will expect the first WL2, right, that is will be there, that will be there. What other item will add? The inertia thing also will add, right, the inertia thing also will add, okay. So, that is nothing but W G, okay, A into H, this is what happened, yeah. So, this is there. So, this is moving in dynamic condition. Suppose the same vehicle stops, what happened to this term? Assuming that the vehicle is at rest, what happened to this term? The inertia will be 0, right. So, the entire term will be goes off, okay. That means NFA into L equal to WL2. Otherwise, your reaction force at the front axle equal to WL2 by L, which is same as a WFA, right, equation A, yeah, right, which is same as a WFA from equation A. This is what your observation, you can see that. So, just to understand what exactly happening when the vehicle moves in a dynamic condition and taking rest. Now, we will proceed, assuming the vehicle is moving on the road. So, when you are moving on, your NFA into L equal to WL2 WG by AH, that is clear, right. So, this is WL2 by L. I will even more simplify that, okay. Take this the NFA W G A H by L, yeah, that is fine. So, previously we found, okay, previously we find WL2 equal to what? WL2 by L equal to what? WFA, right, that is what we know, that WFA, okay. So, WFA, if you transfer that one plus, right, WAH GL. So, this is the reaction force you would experience when the vehicle moves in dynamic condition, okay. So, what do you understand? I know this is already there, right, this is already there, your reaction force already there. So, what is happening now? What is the thing additionally adding into your front axle? this much weight transfer added, right? Can you see that? Yeah. So this much, when you are applying the things, this much weight is transferred, it's added. From where is added? Somewhere else, right? Somewhere else is added. The vehicle weight is anyway W, that cannot be changed. Vehicle weight is W. So somewhere else it taken and added to the front axles. And what happened to the somewhere else? Maybe I am sure you know NFA, when you see the vertical forces balancing NFA, NRA must be equivalent to W, right? Yeah, must be equivalent to W. Okay, so if I want to find out what will be the NRA, right? W N F A, that's the thing. Yeah. So I'll substitute this. What is the NFA? Already I know that W minus, right? This entire thing WFA plus WAHGL. I think, yeah, this is correct only. Shall I move on to the next slide? Yeah, okay. So if you rewrite again, I am just NRA equal to W minus, I will rechange again, minus WL2 by L, W by G, H by L. Okay. Now, it's obviously you know the answer. W, okay, L equal to L1 minus L1 plus L2, WL2 by L, right. So then this term will WL1 plus WL2 minus WL2 by L minus of WG AH by L. So this term will cancel each other. Finally, your NRA, right, the reaction force at the rear axle WL1 minus of So what is this term called now? The same as the weight added at the rear axle is subtracted, right? This is weight is removed. So that's what you see when the brake is applied. Okay. Yeah. I'm sorry. Yeah. WL1 by L. Thank you. So this is weight removed. This much weight is removed. Right. So whatever we did, it's ideal condition. Whatever we now we found out the reaction forces of the front axle and rear axle in ideal condition. In realistic condition, what happened to the braking effort? What will be the braking effort? How the vehicle stops? The braking force alone is enough, or it has to overcome other forces? See, one thing you should very clear. The force to stop the vehicle, that's a braking force, okay, that's one thing is there. Other than that, the other forces also the brake force should overcome. What are they? Remember when we talked about the machine tool gearbox and automobile gearbox, we said certain forces, tractive effort. Yes, sorry, you were saying something. Rolling resistance. So not only rolling resistance, then you have a drag coefficient, which is the aerodynamic resistance, air resistance, that two thing, and third, it's a very important, your gradient. When the vehicle is moving uphill, so that's also will add up, right? So all those things should do overcome. Not only that, you have to overcome those three resistance plus the braking things. So that's we are going to do in realistic condition now. So what I am going to do, so I will take again the slope in realistic condition. This is the slope, the vehicle is moving upward direction, assuming this is the theta for the gradient aspect, right. This is for gradient aspect. So this is one wheel, this is another wheel, okay. The vehicle is moving like this. Yeah, that's there. So now we have a center of gravity CG, right? We have center of gravity. Center of gravity. It's moving up. So you have inertia this way, right? Inertia Wg by A inertia is there. Then you have a deceleration rate. That's a A. Okay. This is supposed to be the weight will act angularly because it's moving in slope, right? So your W will be there. That's vehicle weight. Of course, you will have a another if you when you divide this when you split the weight, you will have a two components. One component in horizontal direction, other component in vertical component. Okay. So this is fine, right? So from here, if you draw like this, right, this would be your wheelbase L. Again, from center of gravity to rear axle is L2. From center of gravity, front of front axle is L1. Okay, this is fine. Okay, what else we have, right? Your rolling resistance will come into in this direction, right? Rolling resistance will come, and what are the opposing things? Air resistance, rolling resistance, and the gradient. All those things will be coming. Okay. Now I will take it as a this is the aerodynamic resistance R. This is air RA is a air resistance or aerodynamic resistance. Okay. Or else aerodynamic resistance. Okay, that's fine. So still it's very not clear. We have to see the balancing of the forces, right? That we need to find out. Yeah. Tell me. So this will be a reaction forces, right? This will be your reaction forces. This is your reaction forces. NFA, front axle reaction force, and this is your rear axle reaction force. That's fine. What else you expect now? Apart from, you will have a rolling resistance also, right? Rolling resistance will move the oppose the vehicle movement, right? So rolling resistance, I will say RR. One R is missing. Rolling resistance. It's a rolling resistance. Okay, RR. So RR you can have FA. RR, FA. Okay, that's the front axle. Again, you will have a RR, RA also. Okay. So now we have rolling resistance. Okay. Now when you apply a brake, what do you expect? Where will be the braking force? To stop, vehicle is moving in this direction. Please understand that the vehicle is moving in this direction. The braking force you would expect in this direction, right? Yeah. Another braking force will come here. So PB, I will say PB, RA, right? And this is PB, FA. PB is suffix actually. PB is a braking force. waves. Okay. Anything else did we miss in now? I think we covered, right? Generally, your braking force, right? The braking force PB supposed to be, right? Your braking torque minus of what? Summation of, right? Summation of I alpha by RW. This is braking force. The braking force mainly related with your braking torque, and this is actually nothing but rolling masses. This is for rolling masses, whereas RW is the tire, okay, tire radius, the tire radius. I alpha is the moment of inertia, alpha is the angular acceleration that is given. Now that is generic, but in realistic condition, the retardation, that overall retardation effect, it's combination of your braking effort, rolling resistance, aerodynamic resistance, gradient, and transmission resistance also there. Transmission resistance also there. Okay. So in fact, I will write down the total retard resistance is summation of your braking force, right? RA is the rolling resistance, okay, rolling resistance plus what do you expect? The plus you expect the gradient W sin theta. Remember, I have given the plus or minus. I will tell you what is the mean plus or minus. That will given. So normally you have a two component. One component will act as a gradient. The other component will interact with the ground. When you interact with the ground, which related to your rolling resistance, right? Mu r W cos theta, okay, plus RT is the your rolling resistance. Okay. Now I will again explain that. This is your gradient. W sin theta is the gradient. Okay. The gradient, right? When do you use the plus? When do you use the minus? Plus when you move up. That's add up your resistance, right? Plus moving up. Minus moving down. Okay, that's what you use it. Yeah, that's the fine. So RT is the rolling resistance. It's a small quantity. RT is a transmission resistance. I'm sorry. It's called transmission resistance. Okay. Now, so the small quantity we can neglect this RT. Okay. How about this component mu r W cos theta? Already I mentioned that mu r is the, what is the mu r? Coefficient of friction in rolling, right? Rolling coefficient of friction. Rolling coefficient of friction. Okay. What is the typical value? Mu r equal to 0.02, 0.03. So W is the weight of the vehicle. Cos theta anyway, it will give you, even if it assume as 0, you will have maximum load. But with that, if you multiply 0.02, do you think that makes sense? Doesn't, right? So we will omit that term also. Okay, we will omit that term. Finally, we will have a, right? Finally, we will have a one thing, right? So we will have the gradient aspect, we will have the braking aspect and rolling aspect. With that, we will try to find out how these forces are acting when the vehicle is braking with respect to front axle as well as rear axle. So from this, I will write the another rewrite the equation. So during braking, during braking. Right. So NFL and front axle with respect to things, okay, L equal to W L2, yeah, plus WGHA minus, right, W H sin theta, that is for your gradient. Then you have a area and distance RA also, that is clearly given. So I rewrite the equation now, right. WL2 plus, I will take the W common, H as a common term, H common, if you take it, so I will see this is a WG by A minus, I will take only these two terms, okay, RA minus of WH sin theta. So this is the equation is there, right. Then within that I can take another things, WL2 and H again I will take this common. When you do that, I would expect WG by A minus RA minus W sin theta, okay. And if we want alone the front axle, the reaction forces WL2 plus H, okay, WG by A minus RA W sin theta by L. So this is a, you can take it as a equation 1, okay. So this is, yeah, any doubt? No, cos theta is gone, right. I made it as neglected, right. Mu r W cos theta, mu r is a smaller value. I said we even the first, right, take the cos theta maximum value 1, you will have W into 2% of vehicle weight, is it makes sense? No, right, that is why I have eliminated that term. No?
W into L2.
Yeah.
Into cos theta. W cos theta into L2, because component of W, you have considered W sin theta.
No, see the previously already there. In general equation when you written that, I had a cos theta, mu r into W cos theta, mu r W into cos theta, and here I have taken as a, is clear to you?
That was frictional force.
Yeah, frictional thing. So what happened, cos theta equal to 0 maximum, I have taken the maximum WL21, okay, yeah. So this is the front axle, this is the front axle, clearly you know that front axle, this much what do you call it, this term is a added weighted, right, it is added one. So similarly if I want to for a rear axle, what happened, my reaction force NRA, what do you expect, instead of WL2 you will have a WL1, WL1 plus or minus, it should be minus, it should be minus, then the same term will become, okay. By L. So this is the equation number 2. This is what happened, okay. Now we got the reaction forces both front axle and rear axle, okay. Now we will move on to the next one, yeah. Now what we have now, so now we will take the entire the braking force, we have not considered the braking force, look at the figure again, we will take the braking force, when you take the braking force BB, right, mu r W must be equal to WG by RA, we are talking, so we are talking everything with respect to equilibrium condition. At the moment we are taking the equilibrium condition, right. So but we know this term, right, Wg by A minus Ra minus W sin theta already is known to us, okay, already is known to us, yes. So, when you substitute in equation 1, okay, we make it, take it as a equation number 3, take it as equation number 3, substitute in equation number 1, what do you expect your NFA? NFA equal to, right, W L2 plus H PB mu R W. I am just replacing the entire thing, I am replacing with, sorry, I am replacing with this term and substitute in equation number 1 by L. You can take it as equation number 4. Similarly, for NRA, WL1 minus H will be minus now, PB mu R W by L. This is equation number 5. Okay. So, the mu R is the rolling resistance, okay, it is the rolling friction between the tire and road, okay. But actually, okay, I would like introduce one more thing is called mu S. Mu S is the road adhesion coefficient, okay, road adhesion coefficient. Right. So, road adhesion coefficient nothing but in indicating about in sliding direction, in sliding aspect. Let me ask question, which resistance is more, is a sliding resistance or rolling resistance? Sliding only, right, usually the sliding resistance will be more, that is very it is obvious that any given time your mu S is much greater than your mu R, that is clear, right, right. So, in that case, when do you expect the maximum braking effort? When do you expect the maximum braking effort? When do you expect the maximum braking effort? Right, when do you expect? Your PB max, I am talking about PB max, when do you expect maximum? When PB max should be your road coefficient with the load, right? This is the condition we expect the maximum effort, right? This is where getting maximum braking effort. Right. So, that is as a whole, if you respect to the individual front axle, rear axle, I can rewrite again the PB max, right, PB max FA would depend on my mu S into NA, NFA, right. This equation I take it as a 4, 5, right, 6. Similarly, my PB max depends on for rear axle, right, mu S into NRA. But you know that what is the values of, already you know NA, NFA, NRA also. If substitute them, I would expect the PB max of my front axle mu S, right. I will have entire NFA value, which is nothing but WL2 plus H PB mu S W, okay. I am sorry, I made a mistake here. This should be mu R W divided by L, and you can rewrite again in simplistic way. Take the W alone, you take the load alone and keep it outside, mu S into W. When you do that, you will have L2 plus H PB by W, yeah, PB by W plus mu R divided by L. So, this is the thing, right. So, but we know PBW, what is that? PBW, your maximum braking effort depends on what? Just now I told you in the previous slide, it depends on what? your surface friction. The braking effort is depends on your surface friction, road adhesion friction, right? That's what happens. So we can rewrite again. Your PB max, front axle, mu s w. I'll rewrite again WH PBW, right, plus mu r by L. So the PB by W is nothing but mu s. If I substitute, I expect mu s into W L2 H mu s plus mu r or bracket L. This is what happened. So this is the maximum braking effect you would expect in front axle. You can take it as equation number 8. Then similarly PB max rear axle would be mu s w L1 whatever the term in minus mu s plus mu r by L. So this is equation number 9. Okay. So my question is, what is that you see now? So we have found your braking effort, right, for the front axle and rear axle individually. Yeah. Remember earlier when we talked about activation force, P equal to Mn Mf by C. What is this and what is that? This is the maximum braking effort. It's happening between the road surface and the tire. I'm talking about this term. Alright, this is what happening. Whereas this is happening from where? This is happening from your effort, braking effort. It is coming from your pedal force. Right? From the pedal force to the where? The brake drum aspect. Right? That's what happening. That's what happening. So my question is, as a brake design engineer, what are the things are you looking for? What are the things you are looking for? Look at the equation, right? So your mu s is variable, right? Your mu s is variable. You can have a skiddy road or a bitumen road or else muddy road also. The mu s is variable, and mu r also variable. Okay. Then which one you have to consider during the brake design? Your weight, H and L. Now can you see that how these dimensions are crucial for designing your brake? Can you observe that? So these are the very important thing, okay, but these are very important. Are they fixed or variable? They are fixed. They are fixed values, okay, they are fixed one. So when you talk about designing, you have to take care of your weight, take care of the height and the wheel base that is there, but that again the performance will change based on your road adhesion factor mu s as well as your rolling resistance mu r. Can you see that? Okay. So that's the thing now. Why we are discussing is, even though when you apply a brake, you have already observed that certain amount of weight is transferred from the rear axle to the front axle, right? So when you do that, when this is happening, you have to make sure that the braking effect also should be divided, right? Should be optimized, right? Should be optimized, right? In fact, okay, the distribution of braking forces primarily depends upon your hydraulic pressure and wheel cylinder. When you apply a brake pedal, right? So from the brake pedal fulcrum will go to vacuum booster to master cylinder. From the master cylinder to it goes to the finally wheel cylinder, right? From the wheel cylinder, then it will expand to activate things. That's what happening. So in between, how to optimize it, right? So the distribution of making force between the front and rear axis exactly. So whatever you got PB max and PB max front axle rear axle must be same during the pedaling effect also. Okay. So in fact I will introduce a new term called KB is a brake distribution factor front axle, KB distribution again for rear axle. If I do that, this is PB max front axle, PB max rear axle. Okay. Finally, is boiled down to L2 plus H mu S plus mu R, L1 minus H mu S plus mu R. Can you see that now? The distribution is purely depends upon the vehicle dimension, wheelbase, height, as well as mu R and mu S. Okay. So let me ask one question. When you apply a brake, you would expect the braking forces should be developed same time on the both front axle and rear axles. Then only the vehicle will stop. But in realistic condition, this is valid only for one particular mu s value. The optimum can be maintained only one particular mu s. Okay. But in road condition keep changing. So because of that, either the front will lock first or rear will lock first. That will be there. Okay. So in fact, this is called brake distribution factor KB. So normally the KB, assuming this is KB equal to KB front axle and KB rear axle, right, should be equal to 1. That has to be maintained. That has obviously, right. So if you make a 100% effort, certain portion will go to the front axle, certain remaining has to be go to the rear axle. So any given time your KBF front axle plus KBF rear axle must be equivalent to 1. That cannot be changed. But your load condition keep changing. Okay. So that thing we will discuss in tomorrow lecture. So in fact we are going to discuss in detail what happened when the front axle lock, what are the problem you would expect, and the rear axle locked, what are the problem you are going to accept. Okay. So then how to address the problem, right, which is the most safety in that condition, how do I know which axle will lock first? That's also we will discuss. Okay. So thank you, I will stop now, we will discuss the remaining thing tomorrow lectures. Thank you.